The easiest one for patients to understand is going to be their multi-angle comprehensive or comparison. So we'll just look at it on the screen for the moment. Okay. So then you have your plantar flexors on the left column, dorsiflexors on the right. On the y-axis, you have torque. On the x-axis, you have the position. Okay, so we can see that there's like a gradual increase in plantar flexion force as you get higher and higher. You can see that it's maybe somewhat abnormal to what you would expect as far as like more of like a linear hump. As you get deeper into one's dorsiflexion, you get more passive tension. That passive tension is functional strength. And so as you get deeper into that range, that's the interpretation of why you get an inflection point, because the passive elements is how I'm interpreting that. It's possible that that this patient could have a dip of force at that point, because I would expect that point to otherwise be here, but it's symmetrical and it's bilateral. It would be it would be surprising if there was the same strength decrement on one ankle versus the next. But we can see that across the board that the uninvolved limb, or by convention, this time it was the right side, that there's a decrement between the two. If we look down here, it just gives us the numerical values. So it gives us the angle, it gives us the uninvolved and the involved in foot-pounds, and then it gives us the percent decrement between the 5 different positions. So we're at the tail ends, there's minimal difference here and there, but in the middle there is a rather large delta of up to 39%.
So this is a deficit of right?
Mm-hmm.
But then why is it more force on the involved?
You see how it's a negative?
Oh, I see.
Yeah. It's a negative.
Yeah.
It's a negative between the two. Yep.
I see.
Yeah. So, and yeah, we tested I believe we tested the right first, but I can't recall if it was like up at the top. But regardless, you would, you would know clearly the involved would be tested second by convention. And then when you look at the strength curve of the dorsiflexors, again, a lot more symmetry compared to the plantar flexors. Again, the area where you show the greatest decrement in your dorsiflexors are at the end range of dorsiflexion. Functionally, that means minimal to nothing for me, because you're already maxed out at your dorsiflexion, right? So I would say dorsiflexors are not an issue here. The other consideration now is looking at torque relative to body weight, right? So that's not going to be shown here. You have a guesstimate of it because you may know the person's body weight of 130 and they're producing at peak 111 and 120 foot-pounds with their plantar flexors. When we look at the normative data within the biodex, I don't know it off the top of my head. Like I do the knee. So and keep in mind that it's in a slightly different position, but it should still pan out comparable. So ankle plantar flexion for females at 30, the lowest speed here is 30 degrees. So anywhere between 43 and 55 divided by their body weight. And in this case, you're clearly over that. But then there has been, when people have done this like on a force plate, standing under a bar, and they do a max plantar flexion contraction, people can get up to 2 times, the elite 3 times body weight. And so I would say I'm happy when people are producing 80% to 100% of body weight, which you're not far off of that in this case. But I think more data needs to come out on these types of protocols to be able to really discern like what we would expect from an isometric standpoint, because it's very plausible that they could be weak on both sides.
Right.
if we looked at the alternative, it would be like peak torque to body weight percentage here, and it would show us across the board for the 30 degrees. So it's starting into your plantar flexion and moving towards your dorsiflexion. So if we went to the last page where you produce the most amount of force, we would see that your peak torque to body weight is anywhere between 76 and 92%. They won't give you the coefficient of variance because there wasn't 3 repetitions.
Oh, I see.
In an isometric test, you can't have work because work is force over distance, right? And so what you do have is impulse. Impulse is the area under the curve. It's what in your isokinetic test, because you get movement, right? Your analogy here would be work in the isokinetic, but here it's impulse, and it's the area under the curve, which could be another important metric. For instance, you could, if we look at the curve analysis in that last position, essentially your let me actually, I think I can do this. Last name. That's interesting. Oh, that's what I wanted. Yeah. Okay. And then if I went to the minus 30, save that, okay, and then I went to minus 30 for the right, and I can do an overlay of them.
Oh.
So what you're looking at here is the plantar flexion contraction, and then here's the dorsiflexion contraction.
Oh.
Right.
Oh.
And so what they're describing is not only, so it's like, yes, there's like 8% difference, but in the peaks, but then the impulse of, in this case, the right limb is more, and that's where you're getting a 20% difference on the printout. Does that make sense? So that's just making the numbers visual.
Cool.
Any other questions here? Okay.